Section 2.5, number 50. Alright, so this is the one, budget overrun for the big dig in Boston. This cost was 484% more than the original estimate. So it's all about how do I set that information up. So they spent $14.6 billion. $14.6 billion. That was, so 14.6 billion is 484% more than the original estimate. What was the original estimate? Okay. So the key, one of the key words there is more. Yeah, so this isn't 484% of the original, it's 484% more than the original. 484% of what? Yeah, well, what's X represent? So let's start there. What's X going to equal? What do I not know?
The original.
The original. I don't know the original. That's probably going to be at least related to the variable. Right? Maybe it's not X exactly, but it's got what I don't know is going to be related to the variable. Here, it's the only thing I don't know. So that's what I'm going to call X, because I have no idea what the stuff it was. So X is the original estimate. It's a funky blue. And now you can pretty much translate this. Now, the mistake people make is they'll do 48 or 84% of this. These numbers never do anything together. This came from this acting on what? 484% of what? The original. And what was the original? So I increased this by how much? 484% of X. So how do I write 484% as a number? Not a percentage. 4.84 of the original. X. So this increased by this equals the amount that they actually paid. Does that make sense? I mean, that's...
Is it X plus 4.84X?
And you don't have to write all the zeros or anything. You just know the answer is going to be in billions of dollars. Right? Yes?
Wait, so why is there two X's again? And not just like X plus 4.8?
So, always, if I go to a restaurant, it's $30, and I want to pay 15% tip, what would I take 15% of? Of 30, and then you would add that on, right? What if I don't know how much the original was, but I still want to give 15% tip? It would still be original plus tip equals however much money I paid to get out of the restaurant, right? I always like to think of it that way. They hold you hostage. They give you food, you're held hostage, you pay your way out. Please let me leave. Thank you. That's just me. That's a few of us. Is that, I mean, that's a really good question. Why does it show up twice? Because it's involved twice to get the end. I got to start there. I do a percentage of that thing to get to the end. It's exactly the way tips work. Exactly the way markups, discounts. Right? If I had a shirt that costs, I don't know how much, I'm going to take 10% off. That would be the new price. The original minus 10% of the original equals the sale price. That's why it shows up twice, because that's how it gets done in the first place. Even if I knew what the number was, it would show up twice. Anything else from homework stuff? Or even that one, if that didn't make sense, you can ask more questions about that one. Did you carry a decent, or this one here, or that stuff? Yeah?
Number 96 on 2.6.
96. Much gross. Do you see how they have that fraction multiplier? We're looking at that one, right?
Yeah.
Is that what it is? Yeah. Oh, it would sort of suck to distribute that, wouldn't it? So let's not. Let's not distribute it. I mean, you could. Nothing wrong with that. But I would rather kill my fractions from the get-go. Do I multiply this side by to kill this guy?
5.
Yeah, so the mistake people, not just 5, but 5 over 4. See how that will kill? Now again, why am I allowed to do that? Because this is an inequality that has two sides. I can't just do that to something sitting there. So some people, if I give them the problem 4/7 divided by 5/9, they'll multiply both sides. No, there's not two sides. This is a problem sitting there. There's no equals. There's no two sides. Can't do shit to it then, because then you'll change the problem. Here I've got two sides. I can do the same thing to both sides. Keeps the balance. Cool. And you know, a really, really fundamental example of what I'm saying is this true?
Yes.
If I do the same thing to both sides, do I get something that's still true?
Yes.
Yes, I get a still true statement. Is it the same statement that I had originally?
Yeah.
Not really. It's a different statement, isn't it? But isn't it still true? So as long as you do the same thing to both sides, it maintains the truth of it. So if I had a more applicable to us, if x is 8, and I add 5 to both sides, it's not the same statement, but it's an equivalent statement. You'll see that in the book sometimes. It's an equivalent statement. Because the truth of this and the truth of this are the same. If x is 8, then x plus 5 is 13. Isn't that true? So if this is true, then this is true. And vice versa. Maybe. All right, so coming back to this. If I do this, the other big mistake is somehow a 5/4 stays alive and comes in here. But that's the whole reason I wanted to do this. So I don't have to mess with those fractions. There's only one 5/4. What does it immediately do? It immediately dies. Right? There's no zombie 5/4 that goes through there. Right? There's Rick over here. Before season, whatever the shit went on. 3x plus 4 less than equal to what happens over here? 4 goes into 20. And 5 times 5 is? Alright, that's as far as I'll go. The rest of it should be nice. You can kill the coefficient of some variable piece by multiplying by the reciprocal of that thing. Right? That's how you can always do it. So just to show you a little example, what if I had 7x equals 2 over 5? This is one that freaks people out. The quickest way to do this, what's the reciprocal of 7?
1 over 7.
Yeah, 1 over 7. Now I could divide both sides by 7, but do you see how it's smarter to write it as a fraction because that side already is a fraction? So dividing by 7 is still correct, but isn't division by 7 multiplication by 1/7? They're the same thing. So this idea of multiply by the reciprocal of some coefficient you don't want always works. It's too nice to believe. Dime, whatever. Right? Okay, just to make really sure, this has nothing to do with this problem, right? Just a little side example. I always get somebody come up after and say, how did you get to there? Yeah.
In the homework, for a lot of the questions, we were asking for both set builder notation.
Oh yeah, so set builder, I guess I haven't said this yet. Did I say this? Set builder notation is silly for us.
Because I was trying to, you didn't do a good job of explaining what it
Yeah,
was.
if you get an answer x greater than or equal to 3, set builder looks like this. The set of all x's such that x is greater than or equal to 3. Alright, well that's stupid. I'm sorry. Oh, you guys are like, alright, here's a math guy saying that some math is stupid. It's stupid for us. It's smart when I have to define this in a weird way. Is this, do you see how these are fundamentally saying the same thing? All the x's have to be bigger than or equal to 3. The set of all x's such that x is bigger than or equal to 3. But what if I said the answer was all numbers that start with the letter F? Then I would say x such that the number starts with the letter F. Then I would need set builder, because then I have to build the set of answers some way. Here, I've already got the answers identified. I don't have to build it. So I don't like using set builder notation at this level. You could use it or not. I'm not going to ask you to use it. So in the homework, if you don't use set builder, you're fine.
I use it every time.
If you do use it, you're fine. See, this is funny. Once you get your answer, you just put it in this. And again, the English for this is the set of all x values such that this is true. Which is extra shit we don't need yet. Later in math, you need this. Right now, there's no reason for it. So I think they're just trying to get you ready for it, but it's actually not used that often. Yes?
Number 85.
Sorry for all my colleagues that love that. 85 in the same? 2-6? Was that where we were? The x over 3? No problem? Yeah. So this one, you could pretty much do the same thing we just did. Where'd it go? I totally forgot which one it was. 85? X over 3 minus 4, let's equal to 1. But this one's not that difficult. You could kill the fraction immediately. You could do it after you do one. I mean, you see how, what do you really want to do? You want to get that 4 out of there, right? So you can either move the 4 and then multiply by 3. Or you can multiply everything by 3 first and then move stuff. It really doesn't change the answer. Is that all right? So you can add 4, multiply by 3, you're done. Or you can multiply everything by 3 and then move that thing and you're done. Yes?
One thing I wasn't really clear on for the 2.6 was when we write the interval notation of only one plot, either x or y, where does the infinity symbol goes? Like,
Oh, okay. So it's the difference between like y greater than 7 or y less than or equal to negative 2.
yeah, because like,
You always put the smallest thing it can be, comma, the biggest thing it can be.
it's the smallest thing.
Yeah, so this is greater than 7. So the smallest it can be is almost what? What's the smallest it could be?
Negative infinity.
No. Y bigger than 7.
Oh,
7, almost 7. So if I put this, it's almost 7. What's the biggest it could be? Infinity. Does this have a ceiling? No. Does it have a floor? Yeah, it's like a 7 is the floor. Right. This one, so see how it kind of points you in the direction of where the infinity is going to be on that side. Here, infinity is going to be on that side.
Okay.
Because here, what's the biggest it could be? Negative 2. What should be on the negative 2? Yeah, because it can be inclusive. It can be included. And then how far down can it go? All the way down to negative infinity, yeah. Which really means it's bottomless pit. That one. Bottomless pit. I'll just spit it out.
number 25 on 2.5.
Oh yeah, everybody's favorite section. The top of the John Hancock building in Chicago is a rectangle. If I had to guess, I would guess most of them are rectangular. Whose length is 60 feet more than the width. So again, the people that skip the setup steps are the people that will make the biggest mistakes. Draw a rectangle. What are your 2 players in this problem? Yeah? Length? And width. I love it, right? So draw a picture if it makes sense. So you're not going to draw a little shirt if the problem is the shirt is on sale for 20% off. The little shirt's not going to help. You can if you want to. But here I can label this. It helps me have a visual anchor. Some of us are more visual than others, right? So the length and the width are the players. Which one is going to be just X?
With.
Why would the width be just X?
Because it's a little.
Because I want it. The length is 60 feet more than the width. So the length is dependent on what the width is. So I got to give the width a name first, because then I can build a name for the length. So we can call the width whatever you want to. W, okay. Whoop. And then the length is 60 feet more than that. So how am I going to write that? 60 feet more than this.
W plus 60.
W plus 60. Not 60W. Right. Then you get some really funky answers. Get this building at the top of it looks like this. Really funky. It's like one person wide. You can't. All right, forget it.
That's crazy.
I know. So don't do that to people. Weird ass architect stuff. So this is W, this is W, this is W plus 60, this is W plus 60. So that, if you draw the picture and label everything, the biggest mistake with parameters is people go halfway. They only go halfway around. And then you got this really funky building, right? It's just got a wall and another wall and it's empty. Right, nice hiding place for Godzilla. You ever saw that horrible Matthew Broderick? Not the more recent one with Bryan Cranston. So how do I set this up? What do I know about the perimeter? Yeah, 520 feet. So the perimeter is 520, but from the picture, from the unknowns, what's the perimeter?
Plus W.
Yeah, you can do 2W plus 2W plus 60, because you need 2 W's and you need 2 of these. That's fine. Part of my brain wishes you didn't know any perimeter formulas, because you don't have to. Perimeter is just add up all the sides. There are no perimeter formulas, really. Just add up all the sides. But, you need 2 of those and 2 of those. And now it should be the easy step. All right, once you get the equation, that needs to be the easy step. Solving this sucker. Right. Don't forget units. Don't forget to answer the whole question. Say W equals 10, I've got to be a real dork and say 10 bananas. 10 light years. That's a big building. It's funny joke. Okay, anything else from homework stuff? Yes?
Number 12?
12 and 2.5?
Yeah.
Oh, okay. All right. I love it. Okay, this one is a funky question because of the way they word it. In 2014, Jimmy Johnson won that with the time of that for the 400-mile race. So part of the problem is it gives you all this extra shit you don't need. You gotta wade through it. 400-mile race. At one point, Gordon was 20 miles closer to the finish than he was to the start. So let's do this. This is the start, and this is the finish. So he was 20 miles closer to the finish than he was to the start. So where would I put, where is he right at that point then? Over here.
To the right.
Yeah, he's closer to the finish. He's 20 miles closer to the finish than he was to the start.
80 miles. Isn't it 80 miles?
What is it?
92.
Oh, 80 miles. I don't know where I'm going. 20. Oh, 20 is from the one before that. Sorry. Thank you. So he's 80 miles closer to the finish than to the start. Thank you. So 80 miles closer to the finish than he was to the start. So which one do you have to know first?
Start.
Then to the start.
I have to know the start first. If I knew he was 100 miles from the start and he's 80 miles closer to the finish, if he was 100 miles from the start, how close to the finish is if he's 80 miles closer to it? If he's 100 miles from the start, he's 80 miles closer to the finish line. How far away from the finish line would he be? 20. I love it. Okay. Now, obviously, it doesn't work with the numbers because I just put something out of my head, right? But I did that to get a feel for what I need to know first. I got to know this distance first. So what are you going to call this distance? That's crazy. And what are you going to call this distance? Careful.
X plus
80
X.
Careful. X minus 80. What did we do? If he was 100 here and he's 80 miles closer to the finish, that was 100 minus 80 to get 20, isn't it? So it would be X minus 80, because he's 80 miles closer to the finish than he is to the start. I told you this is a funky one. It's this little diagram you want to trace out for yourself. Now, what's the equation going to be? What's got to be true about these two?
They have to equal 400.
Yeah, they have to add to be 400. The whole thing is 400 miles. So however far he is from the start, plus however far he is to the finish, should be the whole damn thing, which is 400. So you would do this plus this equals 400. Solve that sucker. You guys didn't like that one. That was weird because of the wording. And you're not used to thinking that way. 80 miles closer to here than there. But you got to draw that sucker out. Just like that. Okay. Most favorite section. Some of you guys are just not going to do that and hope I don't notice, but we'll see. Anything else from homework stuff? Yes?
Wait, so why did they give us all the information on Jimmy Johnson?
Exactly. Thank you. So Jimmy Johnson won that with a finish time with that. Doesn't you don't need that. Now, did they do it to be evil? Maybe a little bit. But what happens in real life? Don't we get stuff we don't need for a certain thing we are curious about? Of course there's all, you get everything. And you're like, no, I only want that and that for what I'm talking about right now. So the book's not going to be like, well, here's exactly what you need. No. You have to wade through it a bit. They're going to give you some extra stuff because that's what happens in real life. All right, anything else? Yes?
Not about the homework, but for the test, how do we know which homework, like up to which homework is going to be?
Oh, I'm going to say today. Depends on how far we get today.
We're getting a study guide.
Decent idea of how far. Yes, we are. I have it with me. So just to make sure everybody understands, tomorrow is going to be review day. We're not doing anything new tomorrow. I'm going to have the answer key for the practice test I'm going to give you. I'm going to have that for you tomorrow. You do not have to turn the practice test in, dear God. I've got enough paper already, because I'm going to give you the answer key, so I don't need that turned in. It's just for study. If you don't have time to do it, don't do it. And then, of course, Thursday is our test. First test. The practice test is longer than the actual test will be, which is how I normally do it, right? Because I don't want to try to, what's exactly is going to be on the test yet? Could be in here. Okay, while I'm talking about it, let me give it to you before I forget. Maybe glance at this and then put it away. Yeah.
So like up to 2.5 has to be done by Thursday.
You wish. Yeah, that is hopeful. We have gotten into chapter 3, and I predict we'll get through 3:3. I had my talk with you about homework, how to make it your own. The test is coming, and you're in section 2.2, and the test is through 3.3. What do? You do a little bit out of all the sections you have left. You don't finish like 3 sections and not look at 5. That's insane. You're gonna die on those questions. You start to do a few out of every section. You give what you do to me, and I'm gonna turn it back and say, finish this shit. You're gonna go, I had to do what I had to do. Do you see what I'm saying? I mean, I'm going to uphold my expectations. You're going to go, your expectations are nice, but I can only do this much to get ready for the test. That's the way it works. That's the way school works. That's the way any damn thing works. So we'll have the answer key for this next time. Tomorrow. I'm so used to saying next time.
On absolute values, it's the distance that number is from 0.
Yeah. Yes, which is why the output is always positive or 0. We'll see later in this class that when I have something like this, it would mean the distance between some number and 1. Yeah, but right now, if I just have absolute value in a number, it's how far away the number is from 0.
Okay.
Beautiful. All right. So put that away. You can do it or not. You can at least look at it and see what the test should look like. All right, let's get back into where we left off. I got a little green book today. Yay. I'm going to work out of this sucker. Dude, we didn't quite finish that handout. Is that true? Do we remember that? I know it's a while now. Shoot. Put you there, you are. Ooh, this one? Yeah. Does anybody need one of those? So it's got the blue graphs on it. Okay, more hands than I've got stuff. What happened here? Anybody actually have one? You forgot it.
Oh, yeah, we do. Here.
Thank you. Huh? Sorry. Let's see. I might have one more. No. How did that happen? Okay. Let's do this. Somebody turn out that middle light. Yeah. Cute. So if you have this, go ahead and try to do number 3. I think we did 1 and 2. Try to do number 3. It really is just a plug and chug. So for example, you know what X is. You've got to figure out what Y is for that first row. Second row, you know what Y is. So you just plug in what you know, solve for what you don't know. Try to finish that table first. Like here, number these 1, 2, 3, 4, 1. There's an example. Right, so here you know what X is. So you plug a 2 into the equation. You solve for what you don't know. Y must be 1. That means that equation, if I go to graph it, is going to go through this point. Make sure everybody's doing this right on the second one, the second row here. Y is 3. I want to figure out what x is. I'm trying to complete that point. When y is 3, what's x? X must also be 3. Freak it. So I'm creating points. Up here, this one just points out of nowhere. I can just make the points whatever the hell I want to. That's why there's no order to them. There's no pattern to them necessarily, right? If I get points from an equation, there are specific patterns it will show up in related to that equation. So a line looks a certain way, an x squared looks a certain way. You can listen to my lectures if you need help fall asleep.
Why does the negative just disappear?
Where's that?
Well, you got 2 times 2.
Oh, okay, I skipped a little step. Look here. There are steps to solving this. But can you guys see what this equation right here says? 4 minus what is 3? So how did I solve it? Well, 4 minus what is 3?
-1.
No. 4 minus what is 3? 4 minus 1. So the answer is 1. Now, if you want to see the algebra behind that, if you want to see the algebra behind that, what would you do to solve for y? You would subtract 4. I get negative y equals negative 1. Then how do I kill the negative? And then I get y equals positive 1. So I don't mind if you do a problem, get to a point where you're like, well, of course it's 1. Because that's what you subtract from 4. That's beautiful, because then you're getting out of the weeds. And you're like, here's what the equation says. I can see the answer. That's really awesome. Kicks a lot of ass. Keep going. Right? So in the third row, you know what x is. On the fourth row, you know what x is. So those two are just plug in for x. Yes?
Is the test going to be timed like you do quizzes?
The test will have the whole time, which I guess it's time. You'll have until the end of class for the test, yeah. Because I'm not going to lecture something afterwards. You're going to be brain fried. Nothing would stick. You know, like, nothing sticks anyway. Oh, shit. Yeah. Try to give you the highest chance of stickage of information. So let me catch up to you guys. If I let x be negative 1, let me do it over here. So it'll be 2 times negative 1 minus y equals 3. Let me see what's going on here. Yep. So again, negative 2 minus y equals 3. Just to show all my steps now. Add 2, negative y is 5. So what's y? Negative 5. I love it. So that's the algebra for that guy. Let x be negative 1. That's what this says. And then solve for what y must be. So you're getting these points, but the x and y can't be any damn thing I want them to be. They have to be related to each other through that equation. That's why the graph will have a certain pattern. It will show that relationship. That's why we graph the hell out of everything. It's a beautiful visualization of the relationship. So this is negative 1, negative 5. And when you plug a 0 in, what happens? So I get 2 times 0 minus y equals 3. I'll get negative y equals 3. So I get y is negative 3. So now I've got 4 points that I can plot. And then I connect them up. The reason I connect them is, how many? What could I put? What else could I put here for x? What else could I put? Is there anything I can't put here for x? Like I put a 0 here, right? Couldn't I make another thing that where it's 7? Couldn't I make another thing where it's 1.111112? And another one where it's the square root of 7? And another one, oh shit. I could use every flippin' real number. So what do? I use nice whole numbers so I can plot them. And then I fill it in so I capture all the weird shit in the middle. Every point that line goes through is a point that works in the equation. Are all the points that work in that equation nice? Hell no, right? I could put x as 1.876 and figure out what y is. It's going to be gross, but there's a point that works, right? Do I want to plot that point? No. I'm going to connect and say, look, I just went through all these other points. They're all answers too. So So remember, a line or something, whenever I graph a function, that's a visual representation of all the answers. But what do I use to get it? Nice points that I can actually graph by hand. Can you graph perfectly 1.738 comma negative 2.964? No. No, I can't graph that shit. No. Not by hand. I can barely handle whole numbers by hand. So here we go. That's me. 2, 1. Where's 2, 1? Yeah, over 2, up 1. So there's 2, 1. What quadrant is that in? First quadrant. I like it. First, second, third, fourth. Sweet. 3, 3.
3 over 3.
You almost can't go wrong with 3, 3. The first tells you the x direction, and this is the x-axis. So left and right. The second number tells you up and down. -1, -5.
So the left one.
Stay with me now. Where's that? There it is. 1, 2, 3, 4, 5. I don't know why I do it. All right. And then where am I at? 0, -3.
Stay, then go down.
Stay, and then go down. I like it. Now do you see how, especially if I can find, oh, look at that long ass thing. All right, it's a little overkill, but oh well. That's government work for you. Let's see. Sure. So the minute I connect them, that point, whatever that freaky ass point is, it works. So it looks like it's maybe 0.8, negative 1.5, whatever. Whatever that point is, it works. That's why we fill it in. This is a straight line because every variable is to a first power. The minute you make a variable to the second power, to the third power, some other power than 1, you're going to get a curve. And some of you guys have seen like x squared, right? What's that called? Parabola, that's right. Sorry. Parabola. You got a parabola and a hyperbola. We'll talk about hyperbolas next later. Hyperbola, maybe you should say that instead. All right, now you guys, now watch. This kind of problem, so this kind of problem is relatively simple because it is plug and chug. You guys ever heard that phrase? I had somebody get offended when I said, so you plug the number in and you chug out what the other number must be, right? Nothing else than that. I was like, what do you think it is? I don't know what I'm saying. All right, well, stop it. Now here I'm going to give you a problem where this is all empty. Now tell me, which letter is the easiest one in this problem to pick numbers for? Why is it X? For what reason is it X? Because if I give a number for X, Y is already solved. I just got to do stuff to it, right? So this is exactly like, I got to know X first, because then Y is easy. Just got to do that stuff to it. If I pick if I pick a number for Y, my answer might be gross. But if I pick a number for X, Y is easy. It's -3 times that plus 2. It's going to be a nice whole number, right? So somebody give me a number to try for X.
-1.
No way. I say that because I actually was thinking -1. You want to do I was really, get out of my head. You want to do a mixture of negatives, positives, and 0 in general. So let's see. Let's pick some numbers for X. What's another good number for X? Always a great number for X is 0. And maybe 1. No way. All right. So everybody try those. Now on a test, I would leave these blank. I'm going to let you pick. The trick is if you pick like 2 and the output is 12 and you don't want to plot it, don't plot it. Erase it or use some other points. What did I use to plot the other one? 4 points. How many points are actually on the line? An infinite number. So who gives a shit which points you use? You don't have to use something that you don't want to. Let's see how these come out. These should come out nice. Is this cool with everybody right here? I mean, this is, I'm letting x be -1, so I'm going to replace x with -1. Then I'm going to replace it with 0, so forth. What's -3 times -1?
3.
Positive 3. Oh, yes, sir.
I didn't need one. I just got to practice this.
Oh, this is the one I gave out last time.
Last time?
Last class. Yeah. We worked on this first two. Does this look familiar? I ran out of extra copies, so sorry, buddy. Okay. So here, -3 times -1 is 3. Plus 2? 5. Sorry, I'm not laughing at you, I'm laughing near you. Near you. It's fair. We all do that. Yeah, exactly. Trust me, I don't care how good we are in math, I do that sometimes. What do you get here?
0.
0 plus 2?
2.
2, that's crazy. What about here? -3 plus 2?
-3.
I like it. And then -6 plus 2?
-4.
Now real quick, do you guys see a pattern here? How much did this go down by?
3.
And see how that's a -3? I mean, some of you guys know what that is all about. Some of you guys know what that -3 is for this line. So we'll talk more about that, but it shouldn't be a surprise that since these points come from a specific relationship between x and y, I see a relationship in the x's and y's. Well, it's like, woo, Jeff, good job, right? There's going to be a relationship because they're coming from some relationship, right? But it is kind of neat to see the numbers. And of course, where's 2 there? See, 0, 2. That 2 is always going to be the 0 piece, right? And the -3 is going to tell you how much that goes up or down by, whatever it is. Whatever number's in that place. So now I just plot these points. -1, 5. Here, I'll give you a little break. -1, 5. 0, 2. 1, -1. 2, -4. And again, if I put a line through them, it's got to go through. If it doesn't go through all of them, then you've done something wrong. Wow. Right? If it doesn't quite go through some, you can just make the points big. That's okay. If you got a point like over here, something is wrong. Yeah, make your points big. If you don't have a straight edge, you can just use a piece of paper or something. You kind of want to be a little careful when you connect those suckers, right? And some of you guys need to invest in graph paper. Right? If I was in my class, I would tell me, get some freaking graph paper, Mr. Waller. Your handwriting is atrocious. And you guys are like, that's the same thing I would say. So there's the idea of how to plot points. Points can just be given to you out of nowhere. They don't have to have any relationship. But if the points come from some relationship, which is what an equation is, it's how x and y are related, then the graph is going to have a pattern to it. Right? If they're all to a first power, it's going to be a straight line. Then later this semester we'll talk looking at squares and square roots and all that kind of stuff and see what they look like. Okay. So let's get into the green book here. There we go. Perfect. I'm going to assume we're all able to graph points. If you're not, you want to come see me. I'm going to go right into this. This is basically a rehash of what we've done, but it's, in nice format. Take like a minute, see if you understand what this first question here is asking you. Just to make sure everybody's on the right track. A solution to this has to have how many parts to it? How many unknowns are there? 2. So a solution's got to have 2 parts. You can't say, well, one answer is 7. What? It's x plus y. That's why there's 2 parts to a point. So can you just list a few solutions for me? So let me just to start us off. Somebody have a suggestion on one solution. All right, keep going. Now don't say anything out loud. List some more solutions. Not out loud. Just write a few down. All right, somebody give me another one. 10, -5, kick ass. Sorry. Oh, -3, 8. -3, 8, sweet. 4, 1, I love it. Why? Yeah, I like the funky shit, but why? You know, why not some easy shit?
0, 5.
0, 5. So also 5, 0. So any of these, if I turn any of these around, isn't it still true? Does that always work? No. It's because this relationship is so damn easy. I want the x piece and the y piece to add to be 5. That's what it says. So all these points have that relationship. Their x piece and their y piece adds to be 5. If we plotted these, it would be a straight line. Blah, blah, blah. So here, you guys do this one. I know we did one just like this a minute ago, but just to make sure everybody's on the right track, and so we can see that same relationship we saw before. Okay, good. Let's see if you remember. No, sweet, good. Wow. Oh shit. Alright, so this should be relatively quick. We've got to plug the x values they give us in and see what the y is. So here I get 0 minus 1. And here I get 2 minus 1. 1. And here I get 4 minus 1.
3.
Real quick, see how order operations, if you're not careful, it's everywhere. So don't think PEMDAS is gone because we're out of chapter 1. It's a grammar of English. Never does it go away. All right. What about this last guy?
-3.
Yeah, -2 minus 1, -3. They put that last dude out of order there, but oh well. Watch, if x goes up by 1, what do the y's do?
2 more.
Up by 2, up by 2, and see how that's a 2? Cool. On one level, it's like, well, yeah. You are just doubling things and then taking 1 away, so they should go up by 2. And now I just have, now what's the point that this creates? 0, -1, 1, 1, 2, 3, -1, -3. And did anybody graph it yet? So if you graph it, 0, -1, 1, 1, 2, 3, and -1, -3. There you go. Good Lord. Jeff? Yes?
On the last one, it was -2, -1. Isn't it a positive?
No, definitely not. So, negative times something is the opposite of that thing. Does that make sense? If I multiply something by a negative, don't I get the opposite of it? What's negative times -5? Positive 5, the opposite, right? So multiplying negatives cancel, because what's the opposite of something? The damn thing, right? What's the opposite of up? Up, right? It's sort of like me saying, okay, turn 180 degrees, Now turn 180 degrees. And it's like, why didn't I just stay this way? I'm in the same direction. So multiplying by negative turns it around halfway. So another negative turns it back. That's why they cancel. Adding, subtracting doesn't do that. When I subtract 1, I go down 1 from where I was. Where did I start? Down 2. So if I started down 2 and I went down 1 more, I'm down 3. I was thinking about it like if I owe somebody $2, I owe somebody else $1. Unfortunately, the negatives don't cancel. I owe $3 total, right? Which would be great. Does that make sense? So yeah, you hear that phrase, 2 negatives cancel, if you are multiplying or dividing. But debts, when you put debts together, the negatives don't cancel. Sorry. Okay, so we've done several like this. It seems to be sort of important. Every time we hit a new function, like if we do one with a square in it, the first thing we'll do is we'll make a table of values to investigate what the hell it looks like. Blah, 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 blah. Okay, so look at this one, page 20. Remember what I said about what does it take for the equation to represent a line? All the powers on my variables have to be to the first power. So which one of these, I love their formatting, but oh well. Which one of these is not linear? Yeah, because it's got a squared. Right? Later we'll learn that this will actually be a downward facing parabola. Right now I just got to know it's not freaking linear. So all of them are linear except this one. Is that cool? The rest of them, every variable that I see is to a first power. We're going to assume that that's just a 5. Okay, how are we doing so far? That's nothing major. So what does it take for an equation to be a linear equation or a linear function is all the variables are to the first power. Now, here's the interesting thing. What is interesting about this point? What's the